Hi, welcome back. We're going to graph some of these polynomial functions kind of just in a rudimentary way. They can get complicated. This is where a graphing calculator comes in real handy, but we're going to use a table of values and we're going to use some of the characteristics that we've learned before. A couple words that we have to know before we go forward is extrema. That's where the graph is going to make some kind of turn. It's either going to turn up or turn down. It turns, the graph turns, changes directions. The extrema will be a relative maximum if you have a high point or if the graph turns down, okay? It's called a relative max. A relative min occurs at a local low point. That's when the graph makes a turn up. And then we call that a relative min. So let me give you an example here. If we were to graph this and we had, okay, so these, I'm going to put the relative mins. This would be a relative min and a relative min. It's a local low spot, relative min. And these would be a relative max because it's a local high spot. Okay. We can also determine the smallest degree that this graph represents by counting the number of terms. This element we're going to use when we're given a graph. We're going to use this information up here when we want to graph. Okay, when we want to graph. This information we're going to use when we're given a graph. Okay, so what you're going to do is if it says, what's the smallest degree this graph could represent? You're going to count the number of turns, hashtag turns. So count the number of turns, and then you're going to add 1 to that. That's going to be the smallest degree possible that a graph represents. Okay. All right, so let's get down to graphing. You're going to be provided with like a table of values and some x values, and then you're going to calculate the f of x. If I were you, I would use synthetic division, or you just for extra practice, or you could use just plugging in normally like we've done before, okay? But we're going to make a table of values. And so when I calculated these x values, I got 9, negative 1. When I plugged in a 0, I got 1. When I plugged in a 1, I got negative 3. When I plugged in a 2, I got negative 7. And when I plugged in a 3, I bounced all the way up to 19. Okay? So we can use the degree of the polynomial to help us indicate which way our ends should be going. This is an even, so our ends need to be going in the same direction. And then we can look at the leading coefficient, because the sign of A, in this case, because they're pointing in the same direction, the sign of A will indicate if they both point up or if they both point down. This leading coefficient is equal to positive 1, so that means they're both going to, it's positive, so they're going to both point up. Okay, both of them are going to go up. All right, now we will be asked to determine the consecutive values of x where a real 0 is located. So does it cross or does it touch the x-axis? That's what we're looking for. And we're going to be looking for the consecutive integers. Okay, we can use interval notation on this. So remember, we're going up by 2's. So this is negative 1, and then here is positive 1. I'm going to need this because we're going to, and then this is 3. Okay, all right. So my 0, where it crosses, so let me mark them in red here. I have one here, I have one here, here, and here. So I have 4 of them, okay? All right, so this is going to be between negative 2 and -1. I can tell from my table too, because I go from positive to negative, so I had to cross through 0. It's going to cross again between -1 and 0, because I go from negative to positive. It's going to cross between 0 and 1. These are x values, okay? And then it's going to cross again between 2 and 3, okay? Now we want to estimate the x-coordinate of the relative max or min. Okay, so those are your turning points. This is where it turns. This is where it turns. Okay, so my relative mins are going to be where it opens up, and my relative max is going to be where it opens down. So pick blue. Here's a relative min, and that's going to be at the x of -1. Okay. Here's a relative min. That's going to be an x of -2. Okay, so these are min. And then my max is going to occur, and I usually do all one first, okay, so I don't miss any. And then my max is going to happen at x is 0, okay? And then we're going to state our end behavior. So as x, this is at the arrows, remember? As x goes to -infinity, f of x is going to +infinity, and as x goes to +infinity, f of x is going to +infinity. Remember, the x is your left and right movement, your f of x is your up and down movement, okay? So we always report what's happening left and right, and then is it going up or down? Okay. All right, this next one, we're going to do the exact same thing. This is an odd degree, so we're going to get a little bit different movement. All right, when we make our table of values, we end up with a 5 and a -4 and a -3, 2, 5, 0. And then I also plugged in a 2 and I got a 19. I did that because this, well, I thought it should be a -19. This is -19, sorry. This is going down. I wanted to make sure that there wasn't one more extrema, and so 2 shoots all the way down to -19. So I feel confident in saying that's where all my turns have already been made. Okay, so the degree is an odd, so my arrows point in opposite directions. One's going to go up, one's going to go down. And then it's helpful if we know which is which. So again, we're going to look at the leading coefficient. This is a -1. The sign of AN is negative, okay? So when you're graphing, if you've already graphed it, then if you look at just like an imaginary straight line between your arrows, notice how this is a negative slope. Well, that corresponds to this negative right here, okay, in front, or the sign of A sub n, okay? And that means that your left end has to go up and your right end has to go down, okay? Now we're being asked to determine the consecutive values where the zeros are, so that's where it crosses the x-axis. Boom, 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 okay? So the consecutive values of 0. So here we have 1, 2, 3, 4, between -4 and -3. And then between -2 and -1. And then we actually have 1, 0. So I'm just going to write that as an ordered pair. 1, 0. Okay? This is an actual on this problem. Now we're going to just state the x-coordinates of our relative max and min. Okay, so here's a min, and here's a max. So my min is going to occur, relative min is going to occur at -3. And my relative max is going to occur at 0. Okay? And then we're going to state the end behavior. So remember, here's our end behavior right here. So this is going left and up. All right? So as x goes to -infinity, because it's going left, f of x, I just don't have enough room. Let me erase this. See if I can squeeze it in here. As x goes to -infinity, f of x goes to positive infinity. And then as x goes to positive infinity, f of x is going to -infinity. Sorry, I had to squeeze that in. If you want to ask me questions about that in class tomorrow, I understand completely. Okay? All right, the last thing that we're going to do is reading from a graph that's provided to us. We're going to estimate the x-coordinates of a real relative max or min. We're going to estimate the x-coordinates of the zeros. We're going to determine the smallest degree, and then some of the other features, okay? So we're going to estimate the x-coordinates of the relative max or min. I'm going to say that here is a min. Here's a min. And here's a max. Okay, so my min is at -2, and my max is at a 1. Estimate the coordinates of the zeros. We're going to actually just give the x-coordinates of the zeros. So 1, 2, 3, -3, and -1, and +3. This is a new one. Remember, we talked about this on one of the first slides. Determine the smallest possible degree. Okay, so we're going to count the number of turns, 1, 2, and we're going to add 1 to it. So the degree has to be 3 or more. Okay, and that makes sense because look at our arrows. They're going off in different directions, so we know it has to be odd. And we know it's not a straight line, so it can't be 1, so it has to be 3 or more. We're going to state the domain in the range. The domain is -infinity to positive infinity. And the range is also the same thing. With odd degree polynomials, you're going to have that a lot. Okay, you'll always have -infinity to positive infinity for both of them. It's when you have even degree functions that you might have, you'll probably have you'll use one of your lowest relative min or your relative max. And behaviors, as x goes to -infinity, I'm doing this one, f of x goes to positive infinity. Remember, it's going left and it's going up. Okay, left is always negative, up is always positive. And then as x goes to positive infinity. Here we go. It's going right, so it's positive, and it's going down, so that's negative. F of x is going to negative infinity. Okay, even or odd degree. The ends are opposites, so based on the ends, it's an odd degree. And is our leading coefficient a sub n positive or negative? Well, if I draw a dashed line to represent just an imaginary line between those 2 points, that slope is negative, so a sub n is going to be negative. Okay? All right. Thanks for listening. I'll see you tomorrow.